We've been working on finding the area of various shapes, like a trapezoid, a triangle, and a rectangle. But what do you do if your figure looks like this, where you have a chunk right here that's cut out, and you have some that aren't quite the shapes that we've been finding the area for so far? Well, if we take this figure, we can break it down into shapes that we do know the area for. So let's see where we can do that on here. Okay, looking here, we've got this little dip right in here, this little chunk right here that's taken out of this large rectangle. So let's see if we can still make this rectangle without this chunk. If I go ahead and extend my line here, I now have a large rectangle right here. Okay, and we know that the area of a rectangle equals length times width. So we can go ahead and calculate the area of this portion right here. Well, it gives us a length of 20 feet. So we have the longer side here, our length, that is equal to 20 feet. So we have 20. And then our width, if you notice, we have 18 feet right here, but 18 feet is for this entire line right here. And if you notice, this little portion right here is not included in the new rectangle that we have created. But right here, it's given us a measurement of 16 feet. And if you look at the line right here, it does match up with the line that we made for the rectangle right here. So this whole width of our rectangle right here is just 16 feet. So let's go ahead and put that over there. And if we were going to multiply 20 by 16, you can calculate that out. We can do 20 times 16, and we're going to get 320. Okay, so the area of our rectangle is 320 square feet. So that takes care of this portion right here. But what about these two shapes right here? They are part of this shape, and we do need to account for the area for it. Well, when we look at this, let's see if we can classify what kind of shape this is. Well, looking at it, we have 1, 2, 3, we have 4 lines, so we know it is a quadrilateral. And just like in a previous video that we've done, look here, we have one set of parallel lines. And we know that if we have a quadrilateral with one set of parallel lines, that we have a trapezoid. So we're going to be finding the area of a trapezoid. Okay, and we know the area of a trapezoid is 1/2 times its height times the group of base 1 plus base 2. But right now, we don't have all the information we need. We only have the measurement of one base. Okay? And another thing we're noticing is right here is this line right here and this line. So this base and this base, they are both 5 feet. And in between them is 2 feet. So that's telling me right here that these two shapes are equivalent. So once we find what the missing measurements of one trapezoid is, we will automatically have the missing measurements for the other trapezoid. So let's see if we can use the information we have in this figure to find out what our height and our base are. Let's go back and look at this line right here that's coming up, right here. Okay, we already found out that this line is 20 feet long. So we can say this whole part right here is 20 feet. But there's this little section right here that's not part of these trapezoids. And it's telling us that that length right there is 2 feet. So in order to find out what this part, this base and this base is, we have to subtract 2 from this 20 to get this entire line. So let's go ahead and do that. We have 20 minus 2, which gives us 18. But these two trapezoids share that length of 18. And since we know that they are identical, we know that they are the similar shape, then we could say 18 divided by 2, because we know it's the same exact measurement. And 18 divided by 2 gives us 9. So now we have the length of our base, our other base. So we have 9 feet and 9 feet. So now we have a base of 9 feet and a base of 5 feet, but we still don't have our height. When we look here, we know this entire line right here is 18 feet long. But again, we only want this portion right here because this is the height of our trapezoid. So let's see if we can find another measurement in here that's going to help us figure out what this is. So when we search, we have this line right here that's 16 feet. So that means that this portion right here is also 16 feet because this is a rectangular. So these two shapes these two lines have to have the same length. So that's 16 feet. And right here, we know the whole thing is 18 feet. So if we have this portion here is 16 feet and the entire thing is 18 feet, we just have to find the difference between these two numbers to find out what the length of our height is. So we have 18 minus 16, which gives us 2. So our height of our trapezoid right here is 2 feet. Now we can go back to our formula and begin plugging in all of this information. So we have 1/2 times our height, which we found out to be 2 feet, times the group of base 1 and base 2. Remember, the bases of a trapezoid are the lines that are parallel to one another. So we have one base of 9 plus another base of 5. And now we're just going to solve it out. If we were to take 1/2 times 2, remember all whole numbers can be placed over 1. And when we multiply that out, we have 2 over 2, which is equivalent to 1. Okay, so we have 1 times, and our group right here, 9 plus 5. And if you notice, I just made an oops because I did not follow PEMDAS. So there's a beat the teacher star if any of you got that one. 9 plus 5, I should have done this part first because according to PEMDAS, I have to do what's inside my parentheses first. So let me go ahead, and 9 plus 5 is 14. So what I should have had is 1/2 times 2 times 14, but Mrs. Jeffries made an oops. So let's go ahead and continue on here. We have 1 times 14, which gives us 14 feet squared. But remember, that is only the area for one trapezoid, and we have 2 trapezoids. So we have to make sure we account for both of those when we find the total area. So right now we have the area of our rectangle, which we found out to be 320 feet. So we have 320 feet. Plus we have the 14 feet that one trapezoid was. And again, we have an identical one. It's congruent, it's the same shape, same size, so we need to do 14 feet again. And if I was to add 320 plus 14, I would get 334 plus 14. And if I was to add 334 plus 14, I would get 348. Our measurement is in feet, our units are in feet, and this is area, so we're going to square it. So therefore, the area of our entire shape right here is 348 square feet. Now remember, we had to break this down into shapes that we know, the shapes that we know the area for. So we made one rectangle, one large rectangle here. And then when we did that, it left us with 2 congruent trapezoids. So we found the area of our rectangle, then found the area of our trapezoid, added them all together, and got 348 square feet.